Hey everyone, we have to change our title. Initially, we were trying to map the phytoplankton community composition using IFCB trained model, but we ended up progressing a lot less than expected. So we changed the title to label the PACE data with IFCB data. This work is mainly done by my colleagues at different institutions listed here. There are Antu, Forough, and myself. So phytoplankton, what the idea here is different phytoplankton groups tend to have different pigment composition. So they might change the color in different ways, in subtle ways. Then the traditional multispectral satellites, ocean color sensors, could pick up those differences, but there is a lot of ambiguities there. And that's why PACE is so precious, because the information density on the pixel by pixel basis is a lot higher than traditional multispectral sensors. That's why we're very interested to use PACE data to derive phytoplankton community composition groups. And then to do that, we need to have good models to do the prediction, and we need sea-truth data. And in my opinion, there's no better quality data that can be provided by imaging flow cytobolt, IFCB. Because they basically give each cell a photo shot and then categorize and count different cells one by one. So that's the most reliable data I believe we can ever get when it comes to sorting out different groups of phytoplankton cells. So that's why integrating the two, connecting the two ends, IFCB and PACE, is very exciting to us. So our approach would be just grab on the left hand, grab the features from satellite inputs. In this case, it's the PACE sensors, the three sensors. One is the ocean color sensor. The other two are polarimeters, with the HARP2 having this pretty much the same swath as OCI, but not hyperspectral, multispectral. And then with at specs 1, a hyperspectral polarimeter, but with only like a very narrow swath. So they kind of complement each other. The availability of HARP2 data actually helps with the PACE OCI data potentially, because it can give more information by constraining on the aerosol optical properties. And then the field validation would be the IFCB data distributed across the world. Basically, whatever data we can grab from all over the world, because PACE is a global mission. So our goal is to build up first a matchup table with the input features from satellites, from the PACE. We'll grab the remote sensing reflectance at all the hyperspectral bands, and then we will have columns of labels, which would be ideally the number and volume fractions of phytoplankton cells from different groups. That's our goal for the first step, and then we would go ahead and connect these two data sets, satellite and in situ, and then build an end-to-end machine learning model. So that's a fundamental approach we want to adopt. So we got to as far as for satellite data retrieval, we got to the workflow by Forough Naali. She managed to build up the workflow given a specific time and location. She was able to access the PACE level 3 data and grab all the reflectance measurements at all the bands. from OCI. And the major bottleneck we bump into is the IFCB data process, actually. So I was thinking before the project that there would be off-the-shelf available IFCB data we could play with, but turned out we had to actually, even for the auto-class ready data, we have to analyze them and grouping them, and then actually retrieving them is also a challenge. It takes a lot of time. Antu spent a lot of time on this. But he was finally able to pull those data. But because of the time, we haven't got around to train a model linking OCI data and IFCB's phytoplankton community composition data. And here is the image showing the Cape Cod region, the remote sensing reflectance from PACE at the blue band. This is work done by Forough. But our colleague Zhen actually, her main interest is in the polarimeters. She actually has a preset, pre-assembled training data set, a small training data set to play with. So she managed to play with the modeling part for her data. And this slide shows some initial results from polarimeter. So she basically matched up one type of phytoplankton, which is a cryptophyte here, abundance, and then tried to predict that abundance using various machine learning models after she played with feature importance. And she was able to match different models' prediction of this specific group abundance versus the measurements. As you can see, it's kind of hit or miss. There's still a lot of work to be done. This is just the initial results, but this is the general approach we're trying to get here. So from end to end, basically. And yeah, this is our group. I just want to thank our organizers, Ali and Ryan, for all the help, and also our help desk colleagues for their tremendous support. A lot of interesting discussions and technical troubleshooting helps. And thank you for your attention.